Today we're going to be writing absolute value equations as piecewise functions. Okay, so if you take a look at the top, it says f of x is equal to the set of negative x minus 3, where x is less than or equal to 0, and x minus 3 when x is greater than or equal to 0. We're going to be comparing that to the function, the absolute value of x minus 3. I'm sure you remember now at this point, the absolute value of x looks like this. Let me get back on track right there. Sorry. Looks like that. The vertical shift down 3 units. Gonna move my vertex here. There is no stretch or compression, so we're keeping our shape. This is the absolute value of x minus 3. Let's break this apart into 2 pieces. If you take this graph for the left portion, our slope of this line is down 1, right 1. Rise over run, negative 1 over 1 is negative 1. So our slope is negative 1, so we could write that as negative x. The y-intercept of this function is at 3, so minus 3. If you take a look at the right side of the equation, or of the function, your slope is right 1, up 1, rise over 1, run, 1 over 1. So this is positive 1x. Again, the y-intercept is minus 3, negative 3. From this, I'm trying to get you to see that the absolute value equation can be written as 2 regular linear equations if we constrict the domain. Instead of having it as all real numbers, we want only a portion of it. That is where a piecewise function comes in. See, this left equation is negative x minus 3. So, my recommendation is start at negative 3. From there, we have this line. Notice this, we only want it where x is less than or equal to 0. This is on the left side of the y-axis. We want a closed circle, not an open circle, because the or equal to, and we are going to connect our dots on the left side. The stuff on the right, the dots here, you do not need them, we can erase them. The next portion, positive x minus 3. Starting again at negative 3 at the y-intercept. Dotting my line down and up to have both directions. I'm wanting this one where x is greater than or equal to 0 on the right side of the y-axis. Connect my dots to the right. Hold on, I can do that a little bit better. There we go. Once again, we can erase the excess points to the left. There is our absolute value function. And it is going to look just like, or there's our piecewise that's going to look just like our absolute value. Okay, I'm going to make the recommendation of pausing the video and trying these after I do the first one and seeing if you can figure out the others. We're going to do these 4 problems and call it a day for the day. Okay, our absolute value function is negative absolute value of x plus 2. My recommendation, if you are given the absolute value, if you're given the graph first, write the absolute value. If you're given either function first, do the function first. Okay. So negative absolute value of x plus 2. we have a vertical shift up 2, a reflection over the x-axis. So there's our graph. You can, if you would like to use Desmos, use Desmos to graph these. I encourage you to try these by hand first. Okay, once you have the graph, we're going to identify our slope on the left and right hand side. This is going up 1, right 1. Okay, our slope is 1. Notice the vertex, the x value of the vertex on this graph. It's at 0, 2. We're going to look at the x value to put in our constraint. So we're wanting the graph to be the set. Now our equation, x, the y-intercept of this equation is going to be at 2. So x plus 2, where x is less than or equal to 0. We have the equation x plus 2. We're wanting it up to the y-axis where x is equal to 0. We want it on the left side of that. The other way, the slope is right 1, down 1. So negative x, again, y-intercept, where x is greater than or equal to 0. We're done with the piecewise number 1. Now is the point I'd like for you to pause it if you would and try these. I'm going to go and start writing the answers. Okay, the second one, the absolute value of x, we know there's nothing in front, is rising 1 over 1, so there's no vertical expansion or compression either. It is moving to the left 3 units, so we're going to put a plus 3 inside the absolute value markers. You can add f of x if you want. I'm not going to, just for the point of saving a little bit of room. Alright, for our piecewise, starting on the left line, if we continue this trajectory down, so this slope of negative 1, which I'll go on and start there, negative x, we need to find the y-intercept. So right here, the y value is negative 1, it's negative 2, it's negative 3 if we extend this y-axis down. So it's negative x minus 3. Where our vertex is at negative 3. So x is less than or equal to negative 3. You have a positive slope of 1. X, the y-intercept is at 3. So plus 3. Where x is greater than or equal to negative 3. Alright, j of x. Given the equation, we're going to take negative x minus 1 and going to dash our line down. We want this where x is less than or equal to 1, which is this point. Less than is the left side. For x minus 3, we want it where x is greater than or equal to 1, the right side. I'm removing our extra dots. There's our absolute value function of x. A shift right 1, so minus 1, and down 2, minus 2 on the outside of the absolute value. Okay, moving on. This absolute value equation, all of these are going to be an absolute value of rise and run over 1. So I'm going to go ahead and tell you that. It is flipped upside down over the x-axis, so we need a negative. The vertex is moving to the right 4 units, so minus 4. And it's not moving up or down, so there's our absolute value. Piecewise, you're going to have a positive x slope. Your y-intercept is negative 4. You want this where x is less than or equal to 4. You have a negative x slope. Okay, we're going to continue the line up. There's 1, 2, 3, 4. Positive 4. Where x is greater than or equal to 4. Q of x is x plus 2 minus 5. We're going to go down negative 5 units. 1, 2, 3, 4, 5. Go left 2 units. There's the vertex of our absolute value function. It's a positive slope. Okay, piecewise. The left side of the graph is a negative slope, so negative x. It would cross the x-axis at negative 1, 2, 3, 4, 5, 6, 7 units. 1, 2, 3, 4, 5, 6, 7. 7 units. And we want this to the left of our vertex, so where x is less than or equal to negative 2. The other side is a positive slope, so positive x. The y-intercept is negative 3. And we want this where x is greater than or equal to negative 2. D of x is equal to negative x plus 5. Okay, so we're going to go up to 5. You have a negative slope. And you want this on the left side of 4. Okay, x minus 3. If I could draw straight. You want it on the right side of 4. I'm deleting the excess dots. Absolute value function. It's moving to the right 4. So minus 4. Moving up 1. Plus 1. Take a minute. There's all of them together. And we're going to move on to the last page. I'm going to do placement number 3. I'm going to let you work number 4. And tomorrow, or the next class, I'm going to check your placement 4 for review and to make sure you don't have any questions about this. I was looking to make sure neither one of these were more tricky than one or the other. I would have done the trickier one. Okay. Our first equation is x minus 4. It's a positive slope. We want this. Sorry, I just drew that out of habit. We want this where x is less than or equal to negative or to positive 1. So we want the left side of positive 1, and we want negative x minus 2 where it is on the right side of 1. So there's our function. This has been flipped over the x-axis. We need a negative. It is being a horizontal shift right 1 unit, so minus 1. It's being a vertical shift down 3 units for the vertex. There's our absolute value function finished. Absolute value of x minus 1, that's just our absolute value shifted down 1 unit. Our two equations, the one on the left, down 1, right 1, so negative x. The y-intercept is at negative 1. We want this on the left side of 0, so x is less than or equal to 0. Right 1, up 1, positive x. Y-intercept is again negative 1. We want it on the right side, 0. Last one, and we'll call it done for the day, and let you practice one. Starting with absolute value, we know it's going to be flipped over the x-axis. We know it's a shift to the left 1, so we're going to put plus 1. We know it's been raised up 2, plus 2. We're finished. If you've noticed out of habit, sometimes I'll leave off that second set bracket. You should put that. I'm in the bad habit of not putting it, so I apologize for that. That's why I write it later whenever I see that I didn't put it on. Okay. Our two equations, the one on the left. Again, slope is 1. The y-intercept would be 3 if it continued on that line. And we want this on the left side of negative 1. Our other equation, we're going right 1, down 1, so negative x. The y-intercept here, let me pick a better spot so you can see the y-intercept, is at negative, or positive 1, so plus 1. And we want this where x is greater than or equal to negative 1. Okay, y'all, we're done for the day. If you have any questions, please let me know, and I'll be happy to get back to you.